Let's convert another one of the methods that we wrote using standard recursion into tail recursion. So this example is actually going to be a little complex because Fibonacci has two recursive calls. And that introduces a little bit of an issue when we're trying to make this tail recursive. Because what exactly is our accumulator? Well, we know we're probably going to need one accumulator to keep track of the fib of n minus 1th value. But we actually need two accumulators. So one accumulator is going to keep track of the n minus 1th Fibonacci number, and then the other is going to keep track of the fib of n minus 2nd Fibonacci number, excuse me. Okay, so let's just start writing this, and we'll sort of talk through it. Okay, so the first thing we need to do is, of course, design the driver and the helper method. So remember that we're going to write fib tr helper. We're going to pass in, and then we might give it some other things. So just for now, we'll put fib tr helper. We'll pass in because, of course, this parameter doesn't change. Then we might pass some accumulators. How many accumulators? We don't know just yet. I mean, I did just tell you, but suppose you didn't know. Okay. So now we're going to do static int fib tr helper int n, and again, there might be some accumulators here. We'll get to that when we get to it. Okay. Now we can just copy our case analysis from before. So we're going to do if n is equal to 0. We're going to return something. We don't know what we're going to return yet. We're going to return something. If n is equal to 1, we'll return something else. And then in the other case, the recursive case, we know that this has to be tail recursive. Again, we have to make this tail recursive. How can we make it tail recursive? We put fib tr helper, and then we do some things here. But there cannot be anything either before the recursive call or after the recursive call. Okay. And additionally, one thing that we'll see sometimes is people will write recursive calls inside of other recursive calls. This is no longer tail recursive. The reason why this is no longer tail recursive is because there's something outside of this return. This method call. What is that? It's this method call. So in fact, just like how add 1 is not, this is not tail recursive, this is also not tail recursive because, again, there's a recursive call and there's something else outside of the recursive call, which just so happens to be another recursive call. Okay? So let's get rid of that. So we're going to be doing something to n, and we're probably going to be decrementing it by 1 because we're going to go in steps of computing the nth Fibonacci number. So let's decrement that by 1. But now, what are we going to do? How are we going to compute the previous Fibonacci number and the previous Fibonacci number? Remember, this recursive call is going to compute the nth Fibonacci number. So we want two accumulators. One that's going to store the n minus 1th Fibonacci number, and another that's going to store the n minus 2nd Fibonacci number. Okay? So we're going to have two accumulators. Now, what do you think those are going to be? Or rather, what do you think those starting values are going to be? Well, we actually kind of have a little hint here. Again, the starting values of your accumulators are going to most likely mirror what you return in your base case. So, let's try and see what happens if we return, or if we start out two accumulators where one is 0 and the other is 1. Okay, so that means we're going to have two accumulators. We're going to have one for A and then one for B. Okay, this is just the names that I made up. Now, let's think about this, about how this method's going to work. If n is 0, then what should we return? Well, we could return 0 here. That would be fine. But A is already 0, so why not just return that? Okay? So if n is 1, then we're going to return B. Okay? Because n is already 1. So if we call fib tr of 1, we're going to return 1. If we call fib tr of 0, we're going to return 0. Now, what do you think we're going to do in the case of this? Well, we want to keep track of the previous value, as well as the thing we're going to keep track of the previous Fibonacci number and the previous one. So let's think about this using the diagram. So if we start off with 0 and 1, then this will be the n-2nd Fibonacci number. This will be the n-1th Fibonacci number. And then this will be the nth Fibonacci number. So when we make a recursive call, all we have to do is, so let's think about this with numbers that aren't 0, 1, and 1. So let's say that we're at a little bit later in the sequence. We have 2, 3, and 5. So this is going to be our A, and this is going to be our B. Now, how do we get this value? This is going to be the sum of A and B. And when we make a recursive call, we're going to have, so this is on one recursive call, so we'll call this fibtrh for short. Okay, well actually this is a little bit disingenuous. So the n here is just kind of implicit, whereas A and B are the actual parameters. Okay, so on the next recursive call, we're going to replace A with 3, because in this particular point, now 3 is the previous, 5 is the previous, and the nth is going to be the sum of 3 and 5. So what does that mean? That means that we're going to replace A with B, and B is going to become A plus B. Okay? So Fibonacci is a tough problem to write using tail recursion, and I really encourage you to explore this this algorithm a little bit more in detail. Walk through it yourself. Draw out these diagrams, draw out the stacked frames, and that will really help you to understand this problem. Because on problem set 2, there's a problem that's very, very, very similar to Fibonacci. And if you understand how Fibonacci works, that problem is trivial. And I mean that quite sincerely. Okay? So, remember, A is going to become B, and then B is going to become A plus B. And if that's confusing to you, just remember that actually IntelliJ does a great job of this. It's saying that this first parameter is n, the second parameter is going to be A. It doesn't have the annotation here for some reason, but that's fine. And then B is going to be A plus B. Now remember that these are the values that will happen on the next recursive call, not the current recursive call. So when we recurse, we're going to recurse with one fewer value of n, and then A is going to become B, and then B is going to become A plus B. Okay? So I've taken the standard recursive Fibonacci methods and converted them into tail recursive tests. And of course, well, not of course, but fortunately, all of these pass. But there's one thing we forgot to do. What is that thing we forgot to do? We forgot to make this private.